Okay, sticking with plants for a bit. What we're talking about now is snapdragons, which are a bushy green plant that produces flowers. And the flowers are genetically interesting because they have incomplete dominance. Some plants produce red flowers, some plants produce white flowers, and if you get a heterozygous case, you don't get red or white, you get a pink flower. So, laying out our chart before we dig in here, we're going to have an allele like let's see, I'll use C. They haven't told us anything about the notation here, so I get to make it up. I'm going to use CW for colored white, and I'm going to use CR for the color red. And so the three possible plants are you could have CW, which will produce a white flowered plant. You could have CR, which will produce a red flowered plant. And if you have CWCR, that will give you a pink flowered plant. Um, I don't really have a reason for putting the W before the R. In general, I prefer to do alphabetical order here. And the only reason I wrote W before R is because over here I introduced white before red. And that isn't even the order that they introduced them in the problem here. But because these have neither of them is dominant over the other, I do not think it's critical here that we have these in any particular sequence. So if you're writing R before W, no problem. We should agree on our answer when we get to the end. So they say a pure red snapdragon, well, no kidding, that's the only kind there is crossed with a pure white snapdragon. So we have CRCR crossed with CWCW. Here's the wrong way to do the Punnett Square. CR, CR, CW, CW. Do you see why that's not exactly wrong, but way too much work? Both of these rows are identical. There's no need for both of these. And both of these columns are identical. Really, the Punnett square, if we're going to do one for this case, is ridiculously simple. It's one square. It says the red parent is definitely going to contribute a CR. The white parent is definitely going to contribute a CW, and so it is absolutely guaranteed that the offspring will be CWCR, meaning they will be 100% pink. If you don't want to do a Punnett square for this one, no problem. I don't blame you. I generally wouldn't either. The Punnett square can work, and this is what it will look like, but when there's only one possible allele from each parent, we normally can just skip ahead to the answer and say we'll get 100% heterozygous offspring with pink flowers. Now, things get a little more interesting. They say the F1 offspring are crossed. So if pink flowering plants are crossed with other pink flowering plants, what will the Snapdragon babies look like in the F2 generation? Now we need a actual Punnett square. Give myself a little more space so I can write a little neater. From this parent, we will get either CW or CR. From this parent, we will get either CW or CR. And now, four different offspring, or four squares at least. We can get CW, we can get CW, we can get, this is again CW, I'm trying to keep the order consistent, or we could get CR. And this is what we sometimes call 1 to 2 to 1. We get one white snapdragon here. There are two cases in the middle where we get pink again, and we get one red. So if you see phenotypic ratio 1 to 2 to 1, that's a common thing to see. Or if we do percentages like we normally do, then this is 1 out of 4 white, or 25% white. There are 2 out of 4, meaning 50% of the plants that are pink like their parents. and 1 out of 4 down here, CRCR, which are red flower plants. Draw Punnett Square, check, determine the phenotypic ratio, check, here it is as percentages, or you could say, if you do this, you should give the colors and say it's 1 white to 2 pink to 1 red. If you just say 1 to 2 to 1, we may not be completely happy with that, but this is excellent. This gives all the information and it's nice and condensed.